everybody! Welcome to StrapiConf, the first global Strapi user conference. My name is Anastasia, I'm a product marketer at Strapi, and today I will be the MC of the Adopt track of the conference. Now, we've had so many exciting announcements during the keynote, and I believe that some of you are already rushing to test content internationalization, but no rush. You might want to save it for later and enjoy the talks that our guests prepared first. So today on this stage, we will welcome 8 amazing speakers from all over the world who will share their experience and insights about Strapi and about the ecosystem. If you have any questions to ask our speakers, or if you just want to talk with the sponsors and the community, you can do that in Discord in live mode. So let's get started. For the first talk, we will all virtually travel to Germany to learn how to build a weather alarm app with Strapi. Please welcome our first speaker, Heiko Voigt, lead architect at SIT GmbH.
Thank you, Anastasia, for this kind introduction, and welcome to my talk about using Strapi, Node-RED, and Ionic to build a weather alarm application. I should have come up with a shorter title, you can read the rest of it right here. But anyways, so a couple of things about me. I'm Heiko, my name is Heiko Voigt. I'm a lead software architect at SIT GmbH in Germany. I'm working as a full-stack JavaScript developer, and one of the projects that I've been doing for the last couple of months I want to talk about today. To quickly go through the agenda, we will just take a look at what the customer is and what they're doing. Then we're going to take a look at the business problem that we were facing when we started the project. And when that is done, we'll just take a quick dive into the solution architecture about what we have built. And we're going to take a look at the front end. And then it's demo time. And we're going to take you through all the components that we have built through this demo. And when we're done with the demo, we'll just wrap it up and just take a quick peek on why we think Strapi was a great choice to solve this problem. So about the customer. The customer of mine is a subsidiary of the Ministry of Agriculture in Rhineland-Palatinate. And this subsidiary specifically caters about communication and knowledge sharing between all the market participants in the agricultural sectors. This is, for example, of course, for all the farmers that are out there, but also like meat producers and, of course, the governmental agencies on the European level and the national level in Germany, but also on the provincial level. And also people like agricultural consultants that can work with different farmers on different topics. And based on their technological platform, on their technology platform, they can share knowledge with each other, and they have a communication platform to interact with each other. Additionally, the customer provides base data to work with in the agricultural sector, like weather data, weather outlook, real-time weather prognosis, and all those kind of things, and other topographic information, for example, for crop producers and other things. For our project, there was one relevant component that we have had to work with, and this is the so-called Geobox Messenger. This messenger component is a information system that acts as something like a message-based interface like Slack between all of the market participants that I was referring to, like the farmers, the consultants, the pharmaceutical industry, and they can be used, or they are using this information system to exchange data, to subscribe to information channels that are available on this tool, but also to do direct messaging between each other and to have this work on a mobile environment. Now let's take a quick look at the business problem that the customer is facing. Due to the changes that we have seen in the agricultural sector over the last, I would say, decades, where we have moved from small units to bigger and bigger and bigger units with less market participants, there is a huge demand today for location-based personalized weather and environmental data for your specific situation as a crop producer, for example, or wine producer, fruit producer, whatever you do, to be able to have a kind of a sustainable way of producing your crop, for example. Sustainable means how much pesticide do I have to bring out, and when is the best time to do this? When do I start watering plants? When do I have to cover them? All of these things and that have to be taken into consideration, to have to be done at the right time, at the right moment, and with the right amount of time to prepare for it. And this more or less granulates down to a demand for everything that's location-based, so based down to the specific field where, for example, your plants are growing, or your specific vineyard that might be another 2 or 3 kilometers away from other vineyards that you have that have a different microclimate, and you have to adapt differently to different situations weather-wise. So this has to be huge demand, as I said, for personalized data, location-based. Everything has to be provided centrally, because it's no longer possible for each and every producer to maintain all of the weather information, weather data of his environmental requirements by himself. So this has to be done as a central service, but it has to be personalized for each and every market participant here, and it has to come out on a mobile device, because, well, most of the time, if you're a farmer, you're out on a tractor, you're out within the crop, within your vineyard, and that's where you want to have the information, and that's where you need it, and that's where you have to be able to communicate. Our specific business problem was to give the farmers, especially, the opportunity to book services from this governmental agency based on a location. So this means, for example, if you see right here, you have a farmer with a tablet, and for this specific location he's currently in, he's seeking for weather information and weather warning information in our specific case. So basically he selects his current location from a map, and then the system that we should build returns the available services, weather warning services at this specific location. And then the farmer can book these. For example, say if a drought is coming, I would need to know at least a couple of days ahead so I can start planning watering my plants. Or if it's like in spring or fall time frame, when do I get when do temperatures and humidity drop under a certain level where I have to cover plants and all those kind of things, right? So very simple examples, but these services should be bookable through a mobile device, through Geobox Messenger for the specific farmer in a specific location. That was the use case. And to broaden this up a little bit, we decided to not only build 1 or 2 hard-coded services, but to build a extensible service platform that has a quick ROI for the customer, so we can deploy it quickly. It's cost-effective, and we have a quick time to market with it to bring out these service booking opportunities to the farmers. And also one big consideration for the customer was we had to build it based on open source solutions. And that's exactly what we did. So let's take a quick look at the solution architecture. Well, as I already said, that we already had a base component that we had to use, and we're happy to use it because it's good. This is Geobox Messenger. This is, as I said, a messenger application. So you can have group chats or direct chats, similar to any other platform like MetaMost or Slack. The app itself communicates with any backend services through a centralized data broker, which is called GIM, and this is part of the framework that the application is using. The data broker more or less takes care of moving data in and out of the application instances on the mobile devices. So each mobile device connects only and solely to the data broker, not directly to any endpoint services. And currently, this Messenger app is heavily used already. You can just download it from the App Store. And it has and it comes with a plugin architecture, so you can build plugins based on JavaScript's components and extend this application. That's exactly what we did. So we had a centralized data broker that our services could connect to, and then we have an extendable messenger app that we're building on top of. So the next component that we had to build was the service management component, right? So we want to define services that can be booked from the messenger app. And for that, we need a place where we store our base data. We need to store things, for example, like definitions for weather stations that we want to talk to. We want to define the services itself. So what is a service and how is it defined, and what defines the service, and how does this all work together? And of course, then at some given point in time, we will receive bookings for this service. So somebody out on the application that, yes, I want to use this service, and I'll book it. So we have to store that somewhere, and that's all of that is stored in Strapi. That's what we decided to build in Strapi. The next big component that we had to build was a service runtime. So now that we have defined our services and the users can book the services, we then have to define where do we actually get the data from, and what do the services provide, right? And to do this, we also had to come up with a very flexible and open system, and that's why we decided to build this service runtime on top of Node-RED and have Node-RED talk to Strapi and implement the process flow. So for each and every service that we have one or more service flows in Node-RED defined. The Node-RED itself also keeps track of all the hard data that we need to provide to work with these services, like weather data, for example, to our extent. And it's also doing it connects the management component with the live data that is feeding in, for example, from the weather stations, and then triggers actions inside of the process flows itself. For those of you who don't know what Node-RED is a programming tool. It's a low-code, from my perspective, it's a low-code tool. A lot of you might know it from home automation, because it can talk to literally anything that's accessible through the internet. It brings a flow-based kind of programming model. So you have nodes and flows and data flows. And these process flows are defined by moving data from one node to the other. And each node does something specifically with the data, changes data, and moves it on to the next one. And so with this, you can build very complex application flows that, for example, take data from a web service, work with it, enrich it by calling other web services, pass it on to a database, and then the database does something like with it, computes something, whatever. And that's the basic idea here. It's built on Node.js, and of course it has a huge amount of extensibility points. So the nodes that you can use are technical nodes inside of Node-RED, but a lot of them are talking to external systems like services-based architectures, but also to hardware and IoT devices, whatever basically is accessible through the internet. Node-RED runs on literally anything that is capable of running Node.js. So even from a Raspi up to I think I already have a COS on the mainframe implementation already, whatever that's good for. But anyways, okay. So now let's take a look at what are the artifacts that we have built, right? So on the left-hand side of this chart, you'll see the components that are responsible for handling the booking data from the mobile application. On the right-hand side, you see the components that we've built to manage our services. So if you want to book services, we have to define our services first. And services are defined by a group of parameters that the user can change. For example, as I said, if you want to get a frost warning in place, then we definitely have to define, okay, at what height from ground, for example, do we want to measure? What kind of humidity level do we want to measure? And several other parameters that define such a service. These parameters then have to be moved over to the mobile application to be picked up there, built into the front end. And so the user can define, for example, okay, if it's -2 degrees on 2 meters height, I want to get a warning for my apple trees, because then I might have a problem with the blossoming of my apples, right? So to do that and to come up, for example, with a service, we have to define where this service request is coming from. So what geo-coordinates do you want this service to work on? And to do this, we will have to find a way of defining the location that the farmer selects by reverse coding services, and to map the available services for the specific location for them. So he can pick the services that are available at his specific location, because not every service is available at every location. There are different provinces in Germany, and not every service is available in every province. So we have to do a reverse lookup to check, okay, what services are available at the given coordinates. And then we have to define a couple of other parameters, like the associated weather station, the closest one that we have to monitor for the specific booking. And also we need a reference on where to send any warnings to, which is done by a reference parameter, which is an internal customer ID. So we don't store any personalized data from the farmers or anything besides the geolocation that the service is booked for, and a reference to the customer to send back a message later on in the flow. So let's take a look at a couple of things like what are the use cases for Node-RED and Strapi. And I mentioned that we are talking about weather data. Weather data gets delivered from hard-installed weather stations that are located across the country, and they belong to different weather data networks, and they deliver data into a data repository at the ministry. So we have to define these weather stations that we can actually work on for our services, and that's this basic data comes from a data warehouse component at the customer. And we use Node-RED as well to import these into Strapi, so we can have them as a base data component in Strapi as well. And also we can maintain changes with that. So if a weather station gets decommissioned and a new one gets commissioned, we'll get these changes back and forth. The second use case is the more important one. This is, for example, the way that we build the communication between the data broker that talks to the mobile application, Strapi, and Node-RED in case of one of the services that are the service flows that are working on. So Node-RED, for example, is in our case is waiting for event resources, or an event source. In our case, this could be, for example, a table change in the data warehouse to initiate to say, okay, well, there's a weather station that has sent in a new set of records. If this happens, then we'll kick off a process flow that will look up for respective bookings for this process in Strapi, generate the data, and send it out through the data broker. So this is exactly what is done here. And also Node-RED is keeping track of the data sources itself. So for example, if we talk to a winery, we have different services that we talk to. Then if we talk to, for example, the fruit producer, like someone who's growing apples or other fruit. So there are different data sources and different event sources in Node-RED that then trigger a process flow that gets its base data and its data to work on from Strapi, and then sends out the messages through the data broker. So how does it look like from in such a sample flow? This is for example, what I quickly described here. We get a new event from a weather station. The weather station sends some new data. We then kick off a flow automatically in Node-RED to read the respective bookings for this specific process or for this specific service for a specific weather station from Strapi. We get the data from the weather station. We'll check parameters. As I said, we could, for example, if we say we want to monitor frost in 2 meters height, that's a parameter that the weather station delivers. So we can check, does this match? If so, we'll generate a message. The message gets sent out to the consumer via Firebase. We log that stuff and finish, and we wait for the next message or the next event to occur. Quick look at the front end. The front end is, as I said, is part of the GeoBox Messenger. It's talking to the data broker backend, and we'll definitely came up with a list of services that you have currently booked, and of course you can add a new service to book. This calls a booking wizard, where you just select a geolocation. You then get presented with a list of available services at this location. Then you can define your service by fine-tuning the parameters that you want to monitor. And then you can save that. And this is all done through REST APIs and REST calls that are related through the mobile application, through the data broker to Strapi, right? This is all going back and forth to Strapi. Besides the services that we had for geolocation with Novinatum, that's also called through a REST facade here. And now it's demo time. So let's have a quick look at the Strapi structure. So what have we built on Strapi? And then we're going to take a look at the front-end test application. This is a React application that we use for internal testing. And I'll show you a couple of the Node-RED flows, and then we'll take a look at the Mattermost, the message integration. For the sake of the demo, I hooked up Node-RED to our internal Mattermost chat facility, so we'll see a real-time warning popping up in the Mattermost chat. So that's what we're going to go through, and now we'll switch on over to my browser. And this is of course Strapi as you know it, and these are our collection types that we see right here. So for example, we have the services, and in our system here we have two services booked: Spätfrost Alarm and Pflanzkübel Alarm. Spätfrost Alarm is the use case that I talked about, where you measure a couple of parameters for frost warnings during the night, and that's one that we're going to book later. We have other base data that we need, like provinces over here. Then we have a couple of our parameters that we define. These are all parameters that are related to a specific service, and Strapi takes care of that. I'm going to go through that quickly because I want to show you the bookings here. So these are the bookings that we currently have, and if we sort them, we're going to see that there are 36. The last ID is 36, so keep that in mind because we'll have to look that up later. So Strapi keeps track of all the base data that is coming from the booking system, and also takes care of a lot of the base data that we need to make these services work. Now, if you want to book a service, I said this is our test front end that we came up with. And it's basically doing the same thing that you would do on the mobile app. So you can, for example, select a geolocation. I'm going to do that quickly. It's browse through my map. And I'm going to go, let's go right here. This point here. I can then check my location. So this is the service to the geo reverse lookup. And this gives me my available services at this specific location coming from Strapi. So this was a call for the geo reverse lookup service, and then we asked Strapi for the services that are available. And I want to use the Spätfrost Alarm as I described. Then I can select a couple of parameters, like I said, temperature in 2 meters height. If that goes below 0, I want to have a warning, and I want to have the dew point in 2 meters height also defined as a parameter. And this is for whatever value you're going to set here. And then we can send this booking, and this is the same stuff that happens through the mobile interface, and the abo got created. So if you quickly check back in Strapi, we should now, if you check our abos, we should have a new one. And here, there it is, number 37. And these are our this is our selected location. This is our customer token that we received that we'll need to send messages to later. What we also did here, when the booking gets stored, we're going to select the closest weather station automatically from the list of weather stations, and these are our parameters that we define. Now we have our services defined, we have our services booked. Now let's look at the service implementation. This is Node-RED over here. And what you see right here is a a typical flow in Node-RED, and this is, for example, the flow that I want to show you today for one of the services that we have. And as you see right here, in my sample flow, I'm scanning a directory, right? So I'm waiting for changes on a directory. This could be literally any endpoint. This could be a service endpoint. This could be a socket.io call. This could be a REST service call, because Node-RED can also act as a REST service provider. This can be done on a scheduled basis or whatever you want, right? And then we're going to check for a specific file, which are these two files that we're going to work with, and then we process the flow. So we read the data that's coming from the weather station, we parse the data, do a couple of things with it, and all at the end we format a output message in JavaScript. And this is literally everything that you need to do from a coding perspective in JavaScript. Everything else is just by pointing and clicking and building the respective relations between the nodes. And then you will send this message off to Mattermost, to a specific chat. So how is this working? Let's take a quick look. I have a file that this is, for example, this is one of the simulated things that we have from the weather stations that sends in the data. And if I change this, you should take a look at the left-hand side, the right-hand side here, where all of these actions are taking place, because this is when something happens inside of Node-RED. Now we're going to write this out. Let's cancel this, do it again, change something, write the file again. And with this write of the file, you see there's been a change in here. And when we switch over to our Mattermost channel, and I have to move the window in here so we can see that, just a second. And we just see this is our action message that we just received. It reports there's a frost report for tonight. So this is how we integrate those components. And I have a couple of different flows in here that are working differently depending on the services. And more or less for each and every service, there's a different flow that takes part here and does the respective things with sort of integration from Strapi. Okay, so that was the demo. And now, as I said, that's just a quick summary of why Strapi and Node-RED. Well, we had the goal to build a loosely coupled system, which allows us to extend on literally every angle, right? From beginning at the Messenger app, going through the service management component that allows us to extend literally everything that we want to change in the services and extend the services to any given need. And also from a service runtime perspective, to be able to talk to whatever we want to talk to, whatever comes to the mind of our customers, they were able to do this with Node-RED and Strapi, right? So they can just simply build those components. And also, what's important, all of the interfaces that you've seen are maintained and run by citizen developers. And the two citizen developers that are currently running this system, which currently has 9 services deployed, is done by two. Is run by 2 people, and these guys are actual farmers. They're no IT professionals, they're farmers, right? And that was the goal for this. So for us, Strapi and Node-RED have been a perfect match to bring those components together. We can implement and deploy new services literally within hours. It's really extremely fast and quick. We can build the services independently from their actual implementation in code or in data. And we can build services that combine the existing data plus new data and new service providers and everything into one place. And without changing the services, we can change the data and process implementation that is taking place in the backend, right? So these are completely separated out. And as a true low-code environment, all of this can be maintained, and this was an important part, by citizen developers inside of the customer's organization. So they don't need any IT experts on that. They can basically do it themselves. So that was pretty important for them. That concludes it for today. Thank you very much. I'm available for questions in the chat. And thank you.
Wow, thank you for this presentation, Heiko. It's amazing to know that Strapi helps to develop German agriculture. I hope you have a good harvest this year. Now in the next session, we will meet the person who knows Strapi company website better than anyone else, because she is the person who builds it. And she will show you how right now, so please meet Marion Ott, a front-end developer from Unlikely.
Thank you, Anastasia. So yes, my name is Marion, and I'm working for a French tech company called Unlikely Technology. And we have had the pleasure of working with Strapi for over a year now, mainly on the website that you can see on my screen right now, and also on the website that you are currently using to watch me talk, the StrapiConf website. I myself have been working with Strapi for almost a year. And this gave me the opportunity to really take a deep dive into the Strapi CMS, and I really grew into loving it quite a lot. So this talk is going to be about showing you how to build the structure of some of these website components and showing you some tips that I think can be useful to you, and show you what I really, really like about this tool. Since we don't have a lot of time together, let's get started right away. So we are going to open the content type builder. And the first component that we are going to create is going to be quite useful. We're going to create a link component. It sounds basic, but I think we are more than one to have known the hassle of having to create over and over again a link component with a basic href and label. Here we are going to use it to create it only once and be able to use it everywhere. Thanks to the amazing nested components ability from Strapi. It gives you the opportunity to create a almost limitless component library. All right, let's start. So create a new component that we are going to call link. And we are going to create a category that I'm going to name shared, because it's going to gather all the shared components that are going to be used by our bigger components. And so, like I said before, we need an href, we need the label, and we can also use the enumeration field type that will allow us to add a target field with the only value being blank. I'm not going to add a default value, since I want Strapi to send me back a null response when the target isn't blank. Because mostly the links that I'm going to be using on this website are going to be internal. If it's not the case for you, feel free to go to advanced settings and change the default value here. Let's click finish and save. So let's get started with the navigation. So we need a few things to get it working. We need some panels that you can see here, and each panel can have one or more sections with the title and links, some bottom links, and some push with an image, title, link. Let's start with those. So I'm going to create a component that I'm going to call navigation push. I'm going to create a new category that I'm going to call global. And you'll understand why later. And so the push, like I said, are going to need a title, an image, and a link that we just created before. So we're going to click on component, use an existing component. We're going to call that one link. It's a single component. We only need one. And let's select the link. Finish, save, and done. Now let's create the section component. So we are going to call that one navigation section. Same, global category. And this one is going to need a title and a few links. I told you we would use that one a lot. Another field, component, use an existing component. Links, because it is a repeatable component, we need more than one. And let's select link, finish, save, and done. And now we are going to create the parent of those elements. So the panel. Let's create the navigation panel, which is a global as well. And the panel needs one thing, is an entry point. Component. So it's going to be a link. Finish. And here we also need to add the pushes and the sections. However, Strapi will not show you in the UI those nested components, not to crowd your view too much. So to show you what I'm talking about is if I wanted to add the navigation section or panels, I would not be able to in the UI, but that's all right. We're going to save it. There's another way of doing that. And it's simply by using your code editor and the JSON files generated by Strapi. So open the components folder, global, and then open the navigation panel. Here we go. And now we are going to add the sections, which is a type component. Repeatable, absolutely. And the component we want to use is global, so the category, and then the name of the component, navigation section. Since I'm lazy, I'm going to copy and paste this one underneath and call that one pushes and replace the name right here. And we're done. We're only missing one thing, is the bottom links with the small arrow. Once again, lazy. I'm going to copy paste this one. Call it links because it is a repeatable field. Save. And we should be all right now. Perfect. So you can really see the strengths of Strapi right here in this view with all the level of imbrication of the components. And that's one of the features that make it really, really flexible for a developer. And now we only need one more component, which is the, let's say, the master component that will hold everything. And we are going to be very original, and we are going to call this navigation, which is a global as well. What I like to do when I create new components is to add, most of the time I will add one component, and then I will do everything on the JSON file. I think it's really practical to do that. Let's add an enumeration field again. And we are going to call that one theme, because sometimes on the Strapi website, you can see that the header can be light or dark. It's mostly between white and purple. And in the advanced settings, I'm going to choose light as a default value. Finish, save. And here we are. Now I got my file right here. I'm going to copy this. And the navigation is going to call a single component. It's the panel. And it's a repeatable. You can save that one. And here we are. So that's really something that's very, very practical that I encourage you to do. Try to think about your Strapi components the way you would think about your React components. Think about reusability and think about how you can divide them into smaller parts that you will assemble later on. That's exactly what we did here. All right, now let's get going and create the hero component. So as you can see, there is a title and a text and a few buttons. And actually, this structure can be found in many, many places on the website. You can see it here, obviously. You can also see it here without buttons, but with a label. You can see it right here. If you scroll down even more, right here, and pretty much everywhere on the website. So let's make it a component. So we need a label, a title, a text, and some buttons. So we are going to create a new component. I'm going to call that Edito. I'm going to put it in shared. All right, so a label, title. Let's use the rich text for the text field. Text. Let's use a theme field as well, because sometimes you want the label maybe to be blue or to be purple, to be yellow, or whatever color is your favorite. So theme, I'm going to add purple and yellow. Finish and save. And for the button, it's not really a link, but it's almost a link. It's just basically just a link with a background color. So let's create a button. Create a new component that we are going to call button and that we can use everywhere. Shared. And it will need, once again, a theme field. You can use advanced setting and choose a default value as well. Finish. And it will need, you guessed it, a link. All right. Now I believe we've got everything we need to create the hero. And for this one, I'm going to create a new category I'm going to call slices. For me, the slices are going to later on populate the dynamic zone that we will show you a little bit later. And the slices are basically the elements that will create your page. All right, so an image. And then we got a nested component in this one. I'm going to copy that one. Open the hero. Paste your code. We're going to call that content. It's not repeatable. It's not a navigation panel. It's a shared.editor. All right, sounds good to me. Looks good to me. And here it is. All right, so let's start building at least one page. So let's create a single type. And this one I'm going to call global. And obviously it's going to use the global elements I created before. So most of the time I create a single type called global for all the generic components that I will use on my website. For example, a header or a footer. In this case, we're going to use the navigation. And once again, I'm going to use a very original name and I'm going to call it navigation. Call navigation as a single component. Finish, save. And if we go under single types, global, you can see we got our navigation. So most of the time, Strapi keeps your data. I'm not really sure how that works, but it can become really practical sometimes. Let's say if you deleted the field by mistake and you entered data on it before, if you recreate it using exactly the same field names, you will get your data back. like I just did right here, because to prepare for this talk, I actually created those elements and added some data so I could show you how it's done. But I didn't want to lose too much time by adding multiple links. So here goes. And now we are going to create a new single type, and it's going to be homepage. And on the homepage, what I would like to have is a dynamic zone that will hold all the slices available. I'm going to call that slices. Use existing components. And here you can add, you could call it anything you want, obviously. I could easily add some shared elements in the dynamic zone, but I don't think that would be useful. For me, it's better to keep the shared components in a separate folder. And actually, the slices are going to be using the shared components to become a slice. The shared components are basically small components that help making bigger ones. All right, if you check slices, Strapi will automatically select all the slices that are not currently available in your dynamic zone. I only have one, so that's pretty easy. Finish. Let's save. And let's see how it looks on the front end side. I'm using Next.js. All right. And blank page. Bit disappointing. So sometimes it happens, and sometimes it can be so unnerving trying to find the reason for that, because you made everything correctly and still there's nothing showing up. So if it happens to you, maybe not, I advise you to check out your API endpoint and check out the response. Maybe the answer lies there. And here we go. We get a 4.3, forbidden. That means that there is nothing to worry about. It's just a permission setting that you forgot to check. So you can go back to your Strapi admin, go to settings, and under users and permissions plugin, you can click on roles, public. And if you scroll down, you can see that global and homepage are completely empty. Just check find for both of those, and this will allow the get request to be authorized. And I'm pretty sure we should be able to find something more interesting now. There we go. We got our navigation with our panels, our sections, pushes, and so on. So normally we should be able to see something a bit nicer. Ooh, what's up with that? Not found. Oh, of course. I'm going too fast now. Let's create that home page now. We're going to create the slice hero, add an image, add some content. I'm just going to get that here. All right, so you know what? I'm going to add a label as well. Hello, StrapiConf. And the theme is going to be purple. All right. Save this. How's it going now? Maybe I should publish it. All right. That's better. And here we go. We got our pushes, we got our links, our panel, our hero with our image. And I'm realizing that now we don't have any buttons available for the hero. And that's not a good thing. Well, edito. Did I forgot to add the buttons? Well, apparently I did. Maybe I added some buttons somewhere and I didn't realize. Maybe you did. Sorry about that. Type. Component. Repeatable. slicer, and the component we would like to call is shared button. Okay. Well, here they are. Let's add learn more. It's going to be a yellow button because I really like yellow. Here we are. Done. See, that was pretty easy, huh? All right. So now what we're going to do is add maybe another slice to our website. Let's add this one. And we will be able to use our editor component. All right, so there are two ways to do this. Either you create a collection for the features that you can call with a relational field, or you can just add those manually inside your slice. For the demonstration purpose, I'm going to create a relational field because it's pretty interesting. So what I'm going to do is create a new collection type, and I'm going to call that feature. And a feature requires a title and a text and an icon. A title, text, and icon. Finish. Click save. And now I got a features collection. Once again, luckily I did my homework before, and we got everything available. Now all I need to do is create a slice, and I'm going to call top features. In the slices category, it will have a relational field, a one-to-many relational field because I want to add more than one feature. Finish, click save, and here it is, features. And what we can also add is an intro field, type, yep, component, repeatable. I don't think that's very useful. And the component that we are going to call is editor. All right, how does it look now? Good to me. So we get one thing to do though, because if I go to the home page, I want to add the top features. Oops, it's not available right now. So I need to go to my content type builder, go to the home page, and here you can add a component to be available. And like I said before, I just need to click on slices, and he knows I need one. The top features. Finish, save. And now I only need to call top features. I'm going to take that here. Add my intro, top features. Build that fast, that's true. And you see, this is the relational field. And it knows the features I've got right here. So I only need to click them to add them to my list. And I'm done. I just need to save that. And hopefully, boom, I got my features right here. All right. Something that I wanted to show you as well is that you can also create a collection type that can be pretty useful, that I personally use quite a lot. And it's a universal collection type. Basically, this is all the pages on your website that all have kind of the same structure and that will need pretty much all the same slices, but in whichever order you want. Okay, let's give it a try. So what we want for our universal pages to identify them is, well, we can call that UID, or maybe, you know what? We can just create a simple, oh, it's up to you. I'm going to use a simple text. Save. And here it is, universal. And there's something, well, there you go, Hello Universal, that I created before. And what it's missing is, yep, a dynamic zone. Let's create slices as well. It's always best to keep the same structure everywhere, so it will work in any case. And if I click slices, I should have 2 this time. Yep, top features and hero. Let's finish. Let's save. And since Strapi is pretty smart, it knows already that I added those before to my page. So here it goes. I got a hero. Let's add an image. It was missing. You know what? Let's add a universal label and add the top features. I'm only going to use 3 this time. Yay for features. And the theme is going to be yellow. Boom, boom. Yellow as well. I'm going to save. And so my slug is hello universals. So if I go here and I put slash hello universals, hop, maybe there's a mistake. That's too bad. I hate when that happens. Maybe it's just because, oops, once again, I told you it happens all the time. See, I was already going on my code editor to try and find the mistake in my code, but there you go. There's no mistake, hopefully. Universal, find one, find, save. Okay. Yay, and now it's working. You can see that we are on universal page. We've got our still navigation that's always here, hence the global. And see, we've got our 3 features. I think it's very, very handy because it allows me to create on the go another page right now. StrapiConf. Add a hero. Cool. StrapiConf. Thanks for watching, guys. All right. Don't forget to publish. And here we go. That's pretty cool, right? If you'd like to know how it works, you can just go to your next folder under pages. I just got the dynamic route set up with a slug. And I just created a function called fetch page that allows me to fetch the appropriate data according to a type and a slug if required. For a homepage, for example, I don't need the slug, it's just a type. All right, guys, that's all the time we have together. I hope this talk was nice to you, that you learned some things. I really had a lot of pleasure doing it for you. So let me know what you think, and I hope you enjoy the rest of the conference. See you guys.
Thank you, Marion, for this amazing talk and for our website. If you want to ask Marion a question, you can do it on Discord. And if you want to check Strapi website out, please go to strapi.io. This is not an advertising. Moving right along, it is my pleasure to introduce our next speakers who know for sure how to build a website with 1,000,000 articles. Please meet Bart, Witteveen, and Remko Mantel from Smartshore Ability.
All right, thank you very much, Anastasia. My name is Remko Mantel. You were all expecting maybe Bart Witteveen, but I will start off. First of all, I would like to explain a little bit about the project we did, the RD.nl project. And let's start. These are the topics we're going to talk about, the project a little bit. Bart will tell you about why we chose Strapi. He will tell you about the architecture and the challenges we had. And we will come up with some improvements we think Strapi can improve on. So let's start with the project. The RD project is about Reformatorisch Dagblad, which is one of the newspapers in the Netherlands. It's the biggest religious newspaper in the Netherlands. They have over 25 journalists, editors, you may say, that are using the system. And basically they're using Strapi as a CMS. We start off with a connection with Prestige. Prestige is their system in which they write all the content for the regular physical newspaper, the newspaper itself. Those articles will be imported by us into Strapi. And there's also a connection with AMP, which is a general Dutch press agency. And that enables all the editors to write stories or to adapt the stories a little bit, because you can imagine that news for a website is a bit different than news for a newspaper. Fun facts. At this moment, we have over 900,000 plus articles, almost 1 million. We have over 840,000 assets. The website has about 50 to 70,000 visitors a day. And every day there's about 150 plus of news articles a day. Why Strapi? That's something I will hand over to Bart. So Bart, take it over.
All right, thank you very much. So we were discussing with RD like what type of requirements they had, obviously, for this project. So one of the things that they wanted, I'll just skip over to the next. They wanted something that was a bit more fast, because their old CMS was sometimes a bit slow. And also, I think it's a great addition that that Strapi is fully web-based versus some desktop application. The reasons why we chose Strapi as an option is because it's relatively light, much lighter than their big desktop application in which they used to edit the articles. Also, I think the lock-in is not too much, because the database that you end up with is also relatively simple and only keeps the data that you really want to store. So if at some point, which we hope not, of course, they want to move away from Strapi again, you have you have a simple database that you could migrate somewhere else quite easily, because it's just the data that you have. There's no overhead like some other CMSs have. Except, of course, for some basic tables for users and permissions and that kind of stuff, but not too much, really. Also, it's very scalable. The site that we host for them is, like Remko said, expecting a lot of visitors each day. So we need to be able to scale the website if we need to. Strapi is pretty much stateless, so we can deploy new instances of the same application horizontally, which makes it really powerful to scale if they expect more visitors in certain certain times a day, or even like with any particular news that may come up that causes them to expect a lot of users. We could actually scale up if they have to. Big requirement was for the CMS to be headless, because we wanted to have a more fancy front end, I would say, than most server-side rendered pages. So we're using Vue in the front end, which we'll talk about later. And Strapi allows you to basically pick whatever front end you want, because it's just giving you the data and that's it. And then the last one, already in the earlier conversations with the customer, we realized that they would be asking for quite some customizations. And Strapi is in that way quite easy to extend, simply because it's based on Koa, which is like it's a bit less well known than Express, I would say, but it's a big framework in Node.js world. So it's easy to extend, write middlewares. Strapi plugins offer the same flexibility if you need it to be a bit different than a middleware. So lots of options to customize if you want to. So yeah, that's why we chose in the end to go for Strapi in this solution. Let me move over. I'll try and tell you a bit more about the architecture of the whole thing. So Strapi is, as we'll probably come up to multiple times in this presentation, is really the core of everything at the moment. So we have Strapi in the middle. Then on the bottom left and bottom, you see MySQL and S3, which is basically the way that we store the data persistently. So the database contains the articles for the newspaper, all the tags, categories, all that kind of data that they really edit in their CMS. And then there is the storage of images, pictures, videos, audio, whatever they want to put into the CMS attached to articles. For example, we store it externally in S3. On the left, you will see the daily newspaper system. So they publish every day a new paper. Yeah, of course, except for Sunday, I believe. But so every now and then, depending on the time of day, of course, there's some or a lot of articles coming in, and we have to process them to be published on the website quite quickly. So it's a script that is checking in for new changes coming from their daily paper and then pushing the changes into Strapi through the API that is sort of delivered by default in Strapi. So that's the way that most of the content will be coming in. And then next to that, of course, the editors have their own freedom to edit articles as they wish. On the right, you'll see the search API. It's sort of a separate application that we built custom, mostly because it's a bit bigger than the plugins and the middlewares that we had to build. So we figured it would make more sense as a separate thing in the architecture. Strapi basically pushes article changes in there so that we have a fully working search index for the front end to search on, which will eventually, of course, search in all the almost million articles that they have. And then if people click on a search result in the front end, they will be sent to a page that actually gets all the article data from Strapi again. So it's an index that helps combine stuff together. Then the front end is Vue, Nux to be really precise. We render pages on the server on the first render, and then it's basically a client-only application after that. And then the last part, of course, on the bottom right is this Elasticsearch itself, where we actually store the index. So that's pretty much it, I think. Most of the stuff, of course, that we really did, I think we'll discuss it a bit more later, is actually inside Strapi. So in the architecture, you won't see it as separate parts, but that's something we'll get back to later. Then the challenges we had in this project, and I think Remko is going to tell you about the first one, which is the internal search of Strapi.
Thanks a lot, Bart. When we were halfway in the project, we wanted to import a lot of data. Therefore, I think we imported about 200,000 articles. And one of the first things that the editors came up with was that the internal search within Strapi was not that good. Standardly in Strapi, you can only search on the title of an article, and that's not enough. When you have over 100,000 in this case when testing, but especially on the production environment by now, when you have almost a million articles, it's difficult to search only on the title. So therefore, they needed to have more advanced search capabilities. They wanted to be able to search on author, the whole content of an article, title, date, and a couple of other stuff. So we decided, as Bart said, to build something ourselves with Elasticsearch. So we implemented two search pages, basically the website search as you can see here. And you can search on categories, you can search on relevance, and you can also search on the period. And we also made an internal search, especially for the editors. And as you can see here, it's a bit more. You can also search on category and relevance as on the website itself. But you can also search on a type of article or the length of an article. And you can also search on a tag. This is a specific page within Strapi, and they can simply copy the title of the article, which makes it way more easier to search in the end on an exact title within Strapi. And Bart, over to you again. He's going to talk about the performance.
Yeah, so I think the first time when we talked to people from Strapi about the fact that we use this for such a big website, they were quite surprised, which I think makes sense if you use Strapi out of the box. But therefore we really had to make some adjustments in the way that we handle the data that is going through Strapi to actually make it work. So yeah, almost 1 million articles. I think if you index your database well, that will actually work pretty much fine. But Strapi is also, because you have all the flexibility in your data model, like relationships, the components, the dynamic zones, for example, to name a few. Basically, in the layer of under what you use, of course, they eventually just populate stuff from the database. So they do multiple queries to actually get the data together that you ask for, which is the most resource-consuming part of the getting the data to the client. So we tried to minimize this population as much as we could. And that was, it's quite a challenge, I think, to get that right. And it's also one of the improvements that we will get back to later that we would really like to see in Strapi. But I think we got it working to a point where we at least got to minimize the amount of data that we populate to actually make it a bit quicker. But really, most of the performance improvement comes from, I think, trying to offload the database. And we did that by using Redis, which in our case, in our situation with the website, I think of course, it's a news website. So the content needs to be new. Otherwise, people wouldn't read it. But it's not stuff that changes that much. So we have articles. They publish an article, and if they have a change in an article, it's not a big deal if it would change on the website like 1 minute later than when it's published in some cases. So we use a lot of caching on the website. We basically just stored some of the JSON in Redis, and Strapi being built on top of Koa is making that quite easy because you can just use a middleware to sort of bypass all the calls that Strapi is going to make if you still have a cache available. So yeah, by that we improved the performance a lot, and also I think we managed to get the whole site running on a relatively small database, I would say, for the number of users and data that we have inside. Simply by reusing data that was already taken before and caching it properly. Another challenge. Which is not necessarily a challenge in how it's complex, because I think Strapi made implementing this stuff quite easy. But it was a challenge for us to make it work in big amounts, because there's a lot of stuff that we need to connect to. One of the challenges that sort of came in last, but it's listed first, is that alongside the website that we built, there is another party who is now making their app. So they are consuming the data from same place as our website, which, is of course a really big advantage of using a headless CMS. But it will also make, we consume the data a bit different. So we had to make some changes for that, and also make some separate endpoints, for example, for the application, for the mobile application. So this is all stuff that you can do quite simply in Strapi, just creating a new endpoint using the same data that you already have. So with minor changes, I think in general, we managed to sort of, welcome the other party to build an app on the same platform. So we discussed already before the publishing of a new article. So every time when their paper publishing system is publishing a new article, we have to get it into Strapi as well, which is a script that uses the Strapi API. Then on each change in articles or newly created articles, we have to write changes to the index, because if someone adjusts an article, you want it to be found by the new content, of course, not by whatever was already in there. So we have to keep the index up to date at any time. They are taking weather data from an external party that we have written into a plugin that gets the right data from the weather info. Then we have an additional endpoint searching in an external archive. So besides the articles that they have in our system, there is another archive that contains even more articles than what we have. And every time when someone searches, they will also get, like, alongside whatever we found on our website, we have this many results in the external archive. So it's like an external link that searches also. Also, that is built into a plugin in Strapi. Then, of course, as a new paper, they also have the e-paper, which people can read on another page on the website. And also, that is a plugin that gets the e-paper data to show on the website through an endpoint. So essentially, Strapi became a real big hub for all data that is being taken from different places, pulling from whatever we needed, and using plugins and middlewares. I think we got that done quite easily in Strapi. Of course, the work itself is in writing the plugins, but connecting it to Strapi is really quite easy to set up. Some improvements. We have, of course, run into some stuff that we would like to see different or that we think can be done better. And I think it was also interesting to mention that in this presentation. The first one I discussed a little bit earlier. It's about the population. So I think it's really nice that Strapi offered the components and the dynamic zones, which for like a bit less technical users makes it really easy to build your data model and get basically whatever you want. But it also means that you have to get data from a lot of tables eventually. And that is something we found really, like growing in terms of response time, for example. So if you have a lot of components, a lot of dynamic zones, you can slowly see the response time and the performance going up. So performance going down, response time going up. So that is something I think is could use some work in the way Strapi is set up. And the good thing is that they already have this on the roadmap. So it's actually on planned section already. So I guess it's approved as a feature that they would really like to improve the CMS in. So that's nice to see that this kind of stuff is being improved as well, because it's not something that you would see as a end user with not too much content, because it will be working just fine. But if you use it for bigger projects and you want to use it for bigger projects, maybe, then it's really nice if they make a solid step in improving this, I think. And then the last one, TypeScript. I think that TypeScript, especially in how big Strapi code base can get when you write quite some plugins in middlewares and making it more complex, because you need the functionality, it would be really powerful to have TypeScript support in the project. The services that Strapi offers to query data in your, like anywhere in your application, really would be even more powerful if you get the opportunity to use the type checking there, because you can just see what data is coming in, whether you have certain properties or you don't have certain properties. So if they could manage to get that working, which I think is not really something you have done tomorrow, because it's going to be a lot of work, because Strapi, of course, has developed quite a lot in the last time. So I think it's a lot of work, but it would be really powerful to have it in Strapi. I think they also have it as an option, but this one, whereas the other improvement in population is already planned, I think this one is under consideration. So it's not been decided yet, but we would really, really like to see this, but also understand that it's a lot of work and it won't be done tomorrow. So I think that's it for our presentation. I think you have the opportunity to ask questions on the channel if you want to, and would really like to thank you also, Remko, here for the for being interested in our presentation, and good to have you here. Thank you.
Thank you, Bart and Remko, for sharing this story. That is so impressive. And by the way, great tips on how we could improve Strapi. If you want to check out what features we're going to implement in Strapi in the future, you can go to our public roadmap that's accessible to everyone, and it was actually mentioned in the presentation. And on this note, we're going to wrap up the first part of our sessions. We're going to have a short 15-minute break now, so you can check out the sponsor booth on Discord, talk to our community and sponsors, and to our speakers, of course, and just grab a coffee if it's morning in your time zone, or grab some tea if it's a bit later. So see you in 15 minutes. Welcome back, everybody! I hope that you've had a nice break and now you're ready for the second part of our event. Next up, we have Anisha Malde from IBM talking to us about an interesting journey, 0 to production in 60 days. Now, it may sound like some kind of internet challenge or a horror movie title, but actually this is the reality that COVID-19 created. Anisha is a front-end developer and she will share how she built a showcase platform for the students of UAL to upload and display their artwork to the world. Let's get started. Welcome, Anisha.
Thank you for that introduction, Anastasia. As mentioned, my name is Anisha, and I'm a full-stack developer within the digital agency side of IBM. Most recently, I was technical lead on a project with the University of Arts London, which was a response to COVID-19. The response came about because usually the students of the university have a physical showcase where they can display the work that they've done over the year and a chance for them to get discovered. So if you've heard of Grayson Perry, this is where he was discovered. And for a lot of these students, it's a way into the working world and a way to get discovered by the art community. So we were tasked with building a virtual platform for the students to be able to upload their work, for the university to go in and curate it, give the students awards, and finally for the world to be able to see all the beautiful art that these students have done over the year. So when looking at our options, we came across Strapi because we had a really short deadline of 2 months and a budget, and Strapi met all our requirements. Not only was it really easy to use, it was really well documented. A lot of the developers on our project hadn't heard about Strapi before the project, and within the 2 months were able to pick it up and produce a really great site. And that's what I'd like to demo to you today. So if I head over to the University of Arts London site, you're greeted with this lovely homepage. We can see different collections, which I'll get onto in a minute, but we can see the video from Grayson Perry, and we can see a page which lets us go in and see all the different artwork done by the students. So this page literally just pulls in all the students' work. So it calls Strapi and returns the first 100 projects randomized and has an infinite scroll. So if we scroll down, it will load in the next 100 projects. If we click on one of these projects, we're taken to a student's project page. So if we go into the Strapi interface, we can see that these projects come under collection types. So we can have collection types for the project pages, and for the collections you saw on the home page. The students allowed to then fill in different parts, so they could fill in their college, their course, but what was really cool is we gave them the opportunity to fill in tags. So if we go back to the Strapi interface and go to the content type builder for a project specifically, we can see this field called tags. And what was great about this was when tagged, we could then click on one of these tagged and search all the projects for the same tag. So this would then show us projects tagged body as well. So this student might have tagged their project with body, or they might have mentioned it. So it's like a really quick way to search it. And the way we implemented this search was using Strapi's SDK for JavaScript. And it was really easy because it's just a REST API that we used, which was get entries. And we gave it the parameter for the example I gave of body. What we also had was the ability for the student to create pages within their project. So these pages, again, were a collection type within Strapi called project pages. A student could go in and upload different types of content. So they could upload images, they could upload PDFs, sound, video embeds, 3D, and I think that was about it. So all these images and content types were held within Amazon's S3 bucket. We used CloudFront to help with the rendering. However, after doing my own research, I found out that Strapi also has a really lovely GraphQL playground. So this is just their demo environment, and I've just queried one of the demo content types within Strapi, which was restaurants. So as you can see, this gives us a whole list of the restaurants. So this would have been really nice as GraphQL has its own caching. However, we found that the SDK was pretty quick. As you saw, the search was quite speedy, and with the CloudFront caching system provided by Amazon, our need was sort of fulfilled. However, if I were to go back and do it again, definitely would use the GraphQL endpoint exposed by Strapi. So we can go through the students' project pages. We can see all their lovely work, and a lot of them uploaded their work in different formats. And once we reach the end, we are taken out of the project, back to their project page. Another thing I'd like to talk about is the way we did the dynamic loading of the different college pages. So we had about 8 colleges, and within each college, there were subject areas for different courses. So obviously loads of courses. And if we were to go in and create this manually, we would have been creating about 150 pages individually. What Strapi gave us was a field called slug. So it's the dynamic part of the URL. So if I go to the course collection type, you can see it has a slug, as does the college. So within React, which is what we built our front end on, we were able to use this field type to dynamically load these pages and route them, which saved us loads of time. So as you can see, this is the end part of the slug. But within the React, I'd like to show you how this worked. So within our router in React, we were just given the parameter of the slug, and we gave this to the context provider, which was using the React Context API. And this allowed us to just display that slug really easily and create these pages straight out of the box from Strapi without us having to manually create any pages within React itself. What this also allowed was these colleges and courses to customize their pages. So they could go into Strapi and input custom HTML content into a box and create their custom student work and collections quite easily. So if I go to another one of these colleges, this college might have collections for their personal students, which really gave them these are the collections. It really gave the power to the colleges and the courses to build their page as they wanted to. We also use Storybook with React, which enabled these colleges to create custom content within their pages, which was really nice. So a combination, of Strapi, Storybook, and React is really what made all this possible within the short time frame that we had. So yeah, if you want to be inspired, you can click here. And I was truly inspired by a lot of their work. Having not really understood art before this project, I can say I'm quite in awe of what a lot of these students have built for their graduation, and mine was nowhere near as impressive. So yeah, that's sort of how we use Strapi. Definitely recommend it if you've got a project that has a short deadline and you're looking for something that's really easy to pick up and use, or you're just looking for a headless CMS for a personal project. But they really made this all possible. And yeah, thank you.
Thank you, Anisha. The website looks amazing. Excited to see that you could bring it to life in only 16 days with Strapi. And we are also excited to see Strapi being used for such initiatives and happy to hear your positive feedback. Moving on to our next speaker, who is Arlene Zavala, IT project manager with over 5 years of experience in project management and change management in the IT and hotel industry. Now, if you have watched the Office TV show, you may probably have heard about the company Arlene works for, which is Sandals Resort Sun Services. Let me know in Twitter if you get the reference, and please use the StrapiConf hashtag. So in the next 10 minutes, Arlene will tell you how Strapi can boost productivity and team velocity. Please welcome her on stage.
Hello, my name is Arlene Zavala. I am an IT project manager. And today we're going to be talking about how to boost productivity and team velocity with Strapi. Before we begin, I would like to thank the Strapi team for this opportunity. I am very happy to be here with you today, and I really hope that you enjoy this presentation with me. On today's agenda, we are going to, first I'm going to be telling you a little bit about myself. Then we'll jump to content centralization, deployments and rollbacks, the benefits, and why Strapi. Okay, so As I mentioned, I'm a Honduran that works at TAN services for the Sandals resorts with an overall experience of 8 years in the information technology and hotel industry. I am currently the product owner for the revenue applications in the whole company. I'm also a mom of a 4-year-old. I love plants. I'm a fitness enthusiast. I love wine, the beach, of course, and pizza. So let's begin with content centralization. Strapi helps us create customizable and reusable components and improve our productivity. Why? Because every time we create repeatable components, we are saving time, and we are able to use these components on our different platforms without having to use the same resource to work on something similar or something similar on somewhere else. Instead, we use a component and we pull the data from one end to the other. Here you can see that we have the sections component, which is repeatable, and then we have the name as a text, and then the paragraph, which is also repeatable. And on our right side, we have the list of resorts. So in case you don't know, the Sandals resorts are all over the Caribbean, and we have different resorts on different islands. So each of these codes right here represent a resort that has already been published on our Strapi admin platform. Deployments and rollbacks. Okay, this is a cool one. Deployment times have been reduced to a 90%, which is pretty awesome since we're talking about a website that has over 100 pages. This used to be a little bit of time consuming per se, because even if we were changing an image, we would have to deploy the changes on each of the servers in order for us to see the image on our website. So that has changed hand in hand with the rollbacks. So rollback plans are a click away. We are taking a minimum time period to deploy some changes if in case it's required, or a bug fix, or new images requested by the business, So then we are also able to limit users to specific components. So, for example, we have our teams. Each team has some components assigned to them. That means that I cannot go and change what someone else did if I don't have access to that component, which is pretty cool, because that means that everyone can work on something different at the same time without affecting whatever is being worked on by another team. Benefits. Permissions to each component are 100% customizable. As I said, we can limit them to edit, delete, modify to specific components, not everything. So that is a safe way to work. It allows us to deliver content to multiple platforms. That is something that we enjoy the most, because that is not limiting us to certain applications where we can pull the data from Strapi and insert it somewhere else. And code changes are on the go, so authorized users have the ability to create, modify, or delete content that they have access to. Why Strapi? As I mentioned, as a website with over 100 pages with tons and tons of images with different frameworks in place, the implementation of Strapi has allowed us to adapt our code and centralize all of our static data. Multiple team members can work together and deliver faster results. And it's platform independent. Keyword. So thank you very much. I hope you enjoy the presentation. If in case you have any questions, feel free to ask. My name is Arlene Zavala, and I'm very happy to be here with you today. Ciao.
Thank you for sharing your experience, Arlene. Happy to know that Strapi saves so much time for your team. And I remind you that if you want to ask Arlene a question, please do that in our Discord chat. Moving along, let me introduce you our next speaker, Stanislav Mihić, Senior Software Engineer at -5. Stanislav will tell us how they used Strapi as a publishing platform for the largest local sports betting platform. Please welcome Stanislav on stage. I bet this talk is going to be great.
Hi, my name is Stanislav Mihić. I work as a senior software engineer at -5 company. Title of my presentation is Strapi as publishing platform for the largest local sports betting platform. A few topics I would like to cover in this presentation. First, introduction about our platform, because we are a product-based company. And our main product is a sportsbook. Later I will explain how complex product is and how Strapi fits in perfectly. What is our problem and how Strapi resolve our problem and how it plays together with our platform in production. So about the platform, like I said, we are a product-based company. Our main product is called Sportsbook. It's a cloud-based solution. Right now powering Supersport.hr, Croatian market leader in online and land-based sports betting. It is radar certified solutions. We have covered many digital channels like web, native apps, native mobile apps, bet shops, local store, interactive sport betting terminals. The technology behind our product is based on highly scalable microservices architecture and very progressive technologies, for example NSQ, Golang, and others. Few numbers behind our product. We have 115 million bet slips per year. Our record is 500,000 bet slips in 24 hours, 52,000 bet slips in 60 minutes, and around 20,000 simultaneous sessions by our players, customers. We don't have planned downtimes. We rely on continuous integration, delivery, and deployment. Our uptime is 99.91%. So, what is our problem? Our problem is that we need to have some sort of CMS for independent publishing platform to manage news from the sports world, announcements related to our players, like benefits, bonuses, rewards, new competition games, upcoming sport events, news, and similar. So, bearing in mind that we would like to use our own infrastructure, our development culture, the perfect solution needs to fit in many key topics, like it needs to be a fast, stable, flexible, easy to use, headless, support modern development stack, easy to test and deploy without technology restrictions. It needs to have some sort of enterprise grade features as a CMS, and very important to us, clear future roadmap. We would like to know where it will going in the next few years. From our marketing perspective, which is responsible for adding and editing content, we would like to give them power to work independently without involving a developer for each change, give them possibility to create standalone content editable through user-friendly interface, also give them power to create a new marketing related pages, widgets with sports data, score tables, and similar. So our logical choice is Strapi after we review all available CMS solutions on the market today. This seems a very good fit to play with our product. So our primary use case, and first, we are using Strapi for publishing sports-related content as a blog. So today we have blog posts which are fully managed through the Strapi admin interface. We have multiple authors. Publishing is for them easy and very fast. We're also using schedule publishing, post categorization, and also we have very large flexibility in formatting content in terms that we have embedded videos, score data, upcoming news regarding sport events, and similar. Today we have over 2,100 published posts and counting. On daily basis we have 4 to 5 new blog posts. To the Strapi media library we have uploaded over 11,000 images. Reason for that because we have a different format for desktop web and mobile web. Also each blog post has his own custom graphics in terms that we have assigned to our design team to create image for each blog post which is published through the Strapi. What we like about Strapi, it's administration on first. It is easy and comfortable to use from the marketing team side because they already used it to use some other CMS solutions. For us developers, it's very flexible. It's easy to adjust content and editing experience to the different post types, and also it's very easy to integrate with our platform and other services also. So, publishing flow. We have strong accent on SEO. Especially because we are using a single page application. On the client side we have a simple React app. So we are using Helmet, but for supporting marketing campaigns we need to have enabled solution for post sharing or content sharing. So one of our custom development is site for the Strapi. We have already developed our custom crawler app. It's a simple Express.js app which serve specially formatted title tags for the crawler. For example, for Facebook, Twitter, instant messaging like Viber and similar. We have done some front-end cosmetics using, for example, Strapi URL slug field options, so we have human-readable URLs. And finally, we are able to serve Strapi created content through our platform without the problem. Technology used. We are using official Strapi Docker image, Nomad for handling deployment, MongoDB for our backend database choice, AWS for the hosting, and React for the client side of app. Our Strapi setup is very straightforward. We are using, like I already said, official Strapi Docker image for staging and production. We very like to have different environments, especially staging, where we can test and introduce new features regarding blog or other Strapi generated content, and at the end React is responsible for consuming API generated by Strapi. Our future plans is a little ambitious, but some of them are already realized and on the testing ground. So our major goal is to have single point for adding, managing and editing content. So Strapi will be admin interface, CMS, but we also already introduced recently banner management. Banners is created through the Strapi, and also Strapi is responsible for scheduling when and where this banner will be shown. Also, we would like to have Strapi as a backend part for editing and manage site content, like about us pages, working hour, help and support, and similar. Also, our main feature is to enable other editors to create standalone promo pages, which will follow marketing campaign. So basically, they will have options to create their own landing pages for their newly created marketing campaigns. Also, few feature plans is to have some sort of sport betting offers, widgets, and sport-related content. Well, this is the end. Thank you. If you have any questions, please do not hesitate to contact me directly or through the other channels displayed on this slide. Thank you.
Thank you, Stanislav. It is always great to hear how Strapi empowers not only tech teams, but marketing teams as well. As a marketer, I can relate. Strapi has made my life much easier and I became much more independent. And consequently, I think the developer team is happier as well because they get less requests from my side. Okay, so our next session can rightfully be called a Mythbusters episode. Ekene S from Netlify will disprove all the misconceptions about Jamstack and tell you how to Jamstack in the dynamic era. Please welcome Ekene on stage.
Hello and welcome to my session. The Jamstack way of building the web has evolved a lot and is capable of doing incredibly powerful things. However, we keep hearing things that suggest that the Jamstack is just for static sites. That's what I intend to clear up in this session. My name is Ekene Eze. I'm a developer experience engineer at Netlify, and you can find me on Twitter at Kenny_IO. So let's take a look at my agenda for today. So we'll start off with an understanding of what the Jamstack is and also take a look at some guiding principles that defines a Jamstack site. Next, we'll look at a few benefits of the Jamstack just to shine some light on the different ways building on the Jamstack can help you and your team, and also by extension, your business. We will then look at some common misconceptions about the Jamstack. Of course, there are some. Then, after that, we'll walk through a practical implementation of a Jamstack application with dynamic functionalities that should just help us show you how much you can do on the Jamstack. And finally, we'll take a look at some thoughtful takeaways that I have prepared for you in this session. And that's it. Let's get started. What is the Jamstack? So a lot of people define Jamstack in a lot of different ways. That at some point, it seems like everyone has a different version of what the Jamstack is to them. And that is totally fine, or at least I think it is. But we want people to have the right idea of what the Jamstack is, to at least understand the fundamentals of a Jamstack site before then tailoring it down to suit their respective needs. So Jamstack is a way of thinking about how to build the web, where the UI is compiled, the front end is decoupled from every other service, and the data is pulled in as it is needed, right? So personally, I like to think of it as a way of building an app or a site where my UI is kept separate from other parts of the application. So I have a data source somewhere like in Strapi that I can get more data from whenever I need to. And seeing how that can still be a little bit unclear to others, we've come up with some guiding principles that helps us and also helps you understand the architecture of a Jamstack site. And the first one of those principles is that you should decouple the UI. I already mentioned this in my earlier definition, but this is a very important part of what makes a Jamstack site. So keeping your front end separate from your backend services and databases means that we can deploy your front end to a global CDN, which then serves them directly to your users without any problems. This way, your front end is independent of any complex backend system, but also communicates with them using API when the need arises. And thanks to Netlify functions, this process couldn't get any simpler to implement. Moving on to the next one. The next principle is pre-rendering, right? So before deployment, your entire front end is pre-built into highly optimized pages and assets. As a result of that, the content for your sites are generated at build time, then deployed to a CDN, which then serves all the pages to your users. This makes for an incredibly fast page load speed and an overall better experience, if you ask me. And the last principle that I will talk about is pulling in data as it is needed, right? The global front end uses JavaScript and APIs to talk to backend services, right? Which is how it was designed to function. And this allows pages to be enhanced and personalized as it is needed. So as a result of that, you get all the benefits of serving static assets to your users, but then you get the added power of adding highly dynamic experiences to your site when the need arises as well. So I think it's the better of both sides of the coin, if you ask me. But let's look at the benefits, right? We've been talking about the Jamstack. What does it bring to the table? The first is performance, right? If you notice, page loading speed has a great impact on user experience and on the conversion rate of your site. So when you're working with the Jamstack, you don't generate page views on the server at request time, but instead you generate pages at build time. Then the pages will be deployed directly to a CDN, which is closest to the user, meaning they get to see the content even before they get to the page. Now, as a result of that, we can achieve very high performance on the web without introducing any kind of expensive or complex infrastructure. The next one is scale, right? Popular architectures deal with heavy traffic by adding more logic to cache more popular views and resources, right? But that kind of like is available on the Jamstack by default, right? Sites can be served entirely from a CDN, and that takes away any need for any complex logic or workflow to determine what assets can be cached and when it should be cached. So with the Jamstack, everything can be cached in a CDN. And as a result of that, you get things like simpler deployment and incredible load capacity all out of the box. So security is also something that gets better and easier to manage on the Jamstack. So if you compare it with traditional infrastructures, you'll see that you have fewer systems to protect on the Jamstack, right? More so, sorry. Jamstack pages and assets are all pre-generated. Serving pre-generated files allows for read-only hosting, which also reduces your exposure to attack vectors even further. Since the Jamstack leverages other tools and technologies to extend its capabilities, you can also rely on the security of those tools and services that has teams who are dedicated to securing their specific systems and also providing high levels of service. Strapi, for instance, when working with Strapi, I don't have to do any kind of security on my end as the developer building the product because Strapi has a lot of security features already in place for you to just leverage and build your tool, which is amazing. And let's talk about the developer experience on the Jamstack. It's safe to say that when you're building on the Jamstack, you would not need to learn any kind of proprietary technology or any technology that is so new that no one has heard of it yet just to get things done, right? Instead, the Jamstack relies on widely available tools and conventions that you are already familiar with, that you already know, and that makes it easy to find developers who have the right skills to build out your product. I guess what I'm saying is that building on the Jamstack can take you from feeling like this anytime you're working with your code or you're trying to get things done, and usher you into a whole new world of feeling like this guy who is just cool and having fun. All right, let's talk about some common misconceptions about the Jamstack, because there are some. And the first one is that Jamstack is for static sites. Something that the Jamstack don't rely, since the Jamstack don't rely on traditional server architectures, they come at the cost of powerful dynamic experiences. And that is not true, right? People can think this way if they only believe the Jamstack to simply mean deploy static files to the CDN and serve it to the browsers, like this. But that's not the whole story, right? Jamstack has evolved beyond that, as we'll see in the next slides. The reality is that you can achieve truly dynamic experiences on the Jamstack, right? Jamstack sites are great for creating highly dynamic interactions because they use tools like serverless functions and a variety of third-party services. With serverless functions, for instance, we can perform operations like reaching out to external data sources like Strapi and getting content on demand. If you're also using Cloudinary, you get services like Cloudinary to perform asset transformations in real time. And these are all highly dynamic functionalities that comes to the Jamstack. And there's so much more. And the next thing that we've heard a lot is that Jamstack is not enterprise ready. Well, first of all, that is just a whisper. And this is usually how I respond to whispers. Anyway, some believe the Jamstack to be suited only for small sites like blogs and portfolio sites and so on and so forth. But once again, the Jamstack is currently capable of powering big enterprises, as it is already doing with these ones. Now, these are all enterprises that are currently running on the Jamstack in different ways and in different capacities. I won't get into all of them individually, but I will probably share a link where you can find out more information about these enterprises and how they are using the Jamstack. So the next thing I want to do is take a look at practical implementation of dynamic functionalities on an actual Jamstack site. So let's talk about Jamstack Explorers. The Jamstack Explorers platform is a free platform where you can go on and learn how to build on the Jamstack with a myriad of technologies. At the moment, we have missions on building with Strapi, building with Sanity, building with Noxt, Next.js, and so on and so forth. So to build the site, we needed a CMS to store the missions data. So this includes videos, stages, instructors, what missions we are sending out, and so on and so forth. We also needed a custom database to store the mission progress for users and also to monitor activity on the platform. We needed video manipulation capabilities because we wanted to transform the videos on the fly and render it on our desired formats to the users. Finally, we needed a way to authenticate users and manage access. These are all functionalities that would ordinarily not be achievable in a said static site, but we did achieve it. So what did we do? I'll walk you through it. For our content management and storage needs, we went with a headless CMS. Thanks to teams like Strapi, this step was a breeze, right? The missions data included videos of different stages, instructors, video assets, and so on. And using a headless CMS made modeling the content as simple as possible, and it saved us a lot of time. So for our database needs, we wanted to track user activities on the platform as they progressed through the missions, right? We were tracking things like what stages of the mission have the users completed, what percentage of each video has been watched, and all of that. And we needed a custom database to store all that information and to also use it in different parts of the application as we needed to. So Hasura was great for this. We set it all up without ever having to step too far away from our core front-end skills. And the next thing was video manipulation, which we did with Cloudinary. So for every mission, we needed to automatically generate title cards for those missions. We needed to automatically insert bumper videos at the beginning and at the end of every video we had in a mission. And finally, I think we also needed to automatically set video dimensions, right? Because we had videos coming in from different instructors who are probably recording the videos in different dimensions. So in order to enforce consistency on those videos, we had to automatically set the video dimensions on the fly. And that was a tricky one, but Cloudinary's URL-based APIs made it super approachable, and it helped us save us a lot of time as well. Because we wanted to leverage our existing user base, we needed a way to authenticate users through their Netlify accounts. We used Netlify functions to liaise with our internal OAuth APIs, and it handled it efficiently just with a few environment variables. Again, these are all highly dynamic operations that we handled well within our Jamstack workflow without any problems. So we talked about functions a little bit. So let's take a closer look at how we use Netlify functions on this platform. In the first and existing version of this platform, we used Netlify functions to communicate with Hasura for the activity records that we talked about. Secondly, we used it to communicate with Cloudinary for the video manipulations. And lastly, we used it to communicate with our OAuth APIs for user authentication. But that is not all. We are currently working on the second version of this platform, and we are doing a lot of things with Netlify functions as well. And one of those is communicating with Hasura events for user achievements, because we want to reward users for their achievements, right? So when you finish watching a mission, you get an achievement, and we want to store it somewhere, and we want to do something when you get an achievement, and we're using Netlify functions to communicate with Hasura events for that. Secondly, we will communicate with Hasura webhooks for rewarding and also for monitoring. And lastly, we are communicating with Shopify because we want to generate discount codes on Shopify for each user that has achieved a certain achievement. No pun intended. So what we did to get all of this done is we created a real-time user dashboard, right, that updates in real time. We created custom databases that you can access with both GraphQL and REST APIs. We used a content management system like Strapi. We did on-the-fly video manipulation with Cloudinary, and we did user authentication. Once again, these things are not supposed to be possible on the Jamstack, but we are doing it, and the site is live where you can find out all the details about these things that I'm talking about. What we didn't do, though, is worry about Kubernetes and containers and servers. We remained just front-end engineers, and we didn't have to deal with any of those things that we are not by default comfortable with. We didn't hire a back-end engineer for this as well, so we were just a team of front-end engineers, and we got all of this done well within our skill set. We didn't also go outside our current skill set, right? Everything was JavaScript based, so it needed a little bit of figuring out every now and then, but we didn't have to learn C#, for instance, to get these things done. Another thing we didn't do is pay thousands of dollars for this, right? Every service that we've used up until this point has been free, and the platform has been running for like a year, right? So it saves you cost as well, just building on the Jamstack and leveraging all these other services that helps bring your ideas to life. And the last thing that we did not do is ship this product in 2 years, right? It took us a couple of months, and before you knew it, it was live and everyone was using it. Ordinarily, I would not want to make a calculated guess of how long this would have taken if you went a different direction, but this was relatively fast. So let's talk about my takeaways for you all in this session. And the first thing I want you to take away is, actually, if you can only take away one thing from this session, let it be that Jamstack is not only just capable of powering static sites, but it can power highly dynamic experiences. And not just that, but it also saves you cost. It keeps you comfortable within your strengths. It helps you ship faster, and also gives you a great working experience while you're building on the Jamstack. Okay, let's look at the takeaways that I have for us today. The first one is that Jamstack is not static, right? It is important to understand that Jamstack can still power highly dynamic functionalities. A good example of that is the Jamstack Explorer platform that we just looked at its implementation. Leveraging third-party tools and services, we were able to build a completely dynamic Jamstack application just with a handful of serverless functions. And I think you should be able to take that home from this session, that let's not think about Jamstack as just static sites, right? At the moment, a Jamstack is completely capable of powering highly dynamic functionalities. And the second one is that Jamstack is currently ready for enterprise usage, right? Jamstack is capable of handling very large sites and enterprise applications. And this is many thanks to creative solutions that are continuously arising from the community, mostly about build time optimizations and intelligent caching strategies that we are deploying to handle large Jamstack sites better. And that has made it possible for enterprises to run on the Jamstack with little to zero hassle. Migration policies are easy. At the moment, if you are a Jamstack, or if you're an enterprise looking to get onto the Jamstack, there's a ton of resources that is there available to help you during the migration process and to show you the different strategies that you can employ to make the migration a success. The next one is that the Jamstack has a very mature ecosystem, right? At the moment, the reach of the Jamstack ecosystem is literally on the roof, right? There's a ton of tools and technologies that support the Jamstack model out of the box. And that is including, but not limited to, static site generators like Hugo, Gatsby, Noxt, Next.js, and so on and so on. We also have a very strong community of headless CMS providers like Strapi and a host of others who are all continuously making progress and continuously improving their services to ensure that your experience on the Jamstack is flawless. The next takeaway is that Jamstack is currently being used by millions of developers, right? I think last year we celebrated 1 million developers building on the Jamstack, and that number is much bigger now with the addition of teams and enterprises adopting the Jamstack daily. This, I think, provides some level of confidence, knowing that you're not alone should you run into problems along the way when you're building with the Jamstack. Like, once again, there's a whole ecosystem of Jamstack developers out there creating content, pushing out resources. The framework authors are continuously improving their documentation. So it's not something that you would get into and you'd be scared that you're alone or that you might have questions that no one will have an answer to. That wouldn't be the case on the Jamstack. And the next thing is that the Jamstack will continue to evolve, right? I think at the moment, we are looking at the Jamstack as the future of modern web development. And if that is the case, it will continue to improve, it will continue to evolve, things will continue to get better, and that is to be expected, right? Because at this time, we don't think that there's that there will come a time where the Jamstack will be stuck at a point or will not continuously make progress. So if you think that the services that the Jamstack offers you today or the features you get on the Jamstack is really cool, imagine what it's going to be in the next 2 or 3 years. That is something that kind of personally makes me happy and look forward to the things that will come on the Jamstack. So some other things that I don't think gets appreciated enough is the ease of staying within the confines of your core skills just to build a full stack application while working on the Jamstack. In my example, we were just a team of front-end engineers with little back-end experience, but we were still able to build out the Jamstack Explorer platform and get it out of the way in a matter of months. And that is really cool. Like, I think that's powerful because personally, I just want to be a front-end engineer, right? Things like Docker, containers, Kubernetes, configuring web servers, how does the load balancers work? I personally don't want to have to deal with any of those things, right? And Jamstack makes that possible for me to just write front-end code and everything else is handled for me out of the box. And I think that's ease and that flawless experience that lets you just be who you are is not appreciated enough. So I wanted to call it out again as one of our takeaways for today. And what about the concept of atomic and immutable deploys? So imagine that you have pushed a faulty code to production and something broke and everything is in chaos, right? You have thousands of users all over the world who are trying to access your site and things are just breaking. If you're on the Jamstack, if you're building on the Jamstack, what that means is that you can instantly roll back to the previous version of your site just by the click of a button. And that is possible because of the concept of immutable deploys, which means that your site is built and deployed to the CDN as a bundle and kept like that forever, basically. So if you push new versions of your site, they all get into the CDN, but they are there as different versions. So each deploy that builds and gets served to your users is kept in that state forever. And I think that is amazing because think, for instance, sometime in the future, you want to do some kind of throwback, right? I mean, we've seen companies doing this in recent times, talking about how they started, how far they've come, sending screenshots of their first website that they launched with and what it looks like at the moment, right? If you wanted to do something like that on the Jamstack, you can literally deploy your site's version from 2 years ago and it will still be live as of today, right? And you can possibly take those screenshots and deploy the new version and take more screenshots. And that is something that I think is priceless, to be able to have that capability to do things and have access to different versions of your site at any time in your life cycle is amazing. So these and many more other amazing features are the reasons why we are continuing to evolve the Jamstack model, just to ensure that developing world-class applications and developers out there doing their best have access to modern tools and technologies to get these things done. So let's look at a few ways to get the best out of the Jamstack, right? These ones are really interesting to me because I love to call it out. You might have heard about the Jamstack or building with the Jamstack for a while, but you might not have been making the maximum use of some of the features it offers, which is why I want to call these out, because I find them really interesting. I use them almost in all my Jamstack applications. The first one is for you to use build hooks to monitor events, right? Events like content changes. So take for instance that I'm building an application with Strapi, and I'm connecting into a Nuxt front end, and I'm managing content in Strapi. So basically, what build hooks helps you do is create some kind of event monitoring on Strapi that will tell your Netlify site that some content has changed. So if I change a content and save it and publish it on Strapi, Netlify will get notified of those changes, and you can respond to those events however you want, right? You could say, if the content changes, rebuild my site, or if the content changes, redeploy a new version of the site with that has the current changes that has been deployed. So basically, you can respond to those events however you want, and it's an amazing feature that I don't think a lot of people are taking advantage of. But that is all available on the Jamstack, and you should know about it. So if you're using Netlify and any other CMS or or a platform that supports webhooks, this should be available to you, and you should be taking advantage of that. I think it's amazing. The next one is to use build plugins to perform actions like during your build process, like fetching more data or checking your code's accessibility compliance. And basically what build plugins do is they give you the ability to run custom JavaScript while your site is building, right? And they do this using build plugin events like on success, on error, on end, on start. These events basically just help you hook into your build process and perform other actions you want to do in that life cycle while your site is building. I think that's powerful, right? You have the ability to do really anything you want while your site is building, and that's the capabilities that the build plugin gives us. One of my favorite build plugins is the index one. I think it indexes all of your sites for SEO optimization while your site is still building, not even when it's deployed, and that is amazing. At the moment, there's a ton of build plugins that you can install in your application. There's the Algolia plugin that helps you with search optimization. There's a Gatsby plugin. There's a lot of them, and they do really amazing things. And the good thing is you can really even build your own plugin with a few lines of code. And that is also at the moment not being taken advantage of. I think a lot more people can do a lot more things with build plugins and just create innovative solutions that helps the entire community, not just your team or yourself in your projects. And I think that's a powerful, and people are not using it enough, which is why I'm also calling it out. And the next one is background functions, right? Ordinarily, if you're working on the Jamstack or you're powering these communications between multiple services, we usually go with regular serverless functions. But once you want to perform an operation that takes a little bit of time, then you want to go with background functions, right? Say you're doing video transformations, asset optimizations, file uploads. You want to go and do that with background functions, which will keep running for a longer period of time that serverless functions would ordinarily not be able to run. Also, I don't think a lot of people are using background functions, and that is definitely something you should look at. The next thing I think you can do to get the best out of Jamstack is to put all of your site on Git, right? You can use GitHub, GitLab, whichever one you choose, but putting your site on a Git provider opens a whole new door of awesomeness, right? In terms of workflow and development experience, because you get features like branch deploys, automatic PR review links, reviews, and all of that. And that I think can be amazing because then you can deploy your site in multiple environments if you have access to branch deploys, which you have by default. So you can have branches like QA, development, staging, and production, and you can have multiple versions of your site in all these places just by having them in different branches and taking advantage of branch deploys. That is amazing, and I also don't think a lot of people are using that. The last thing I think you can do to get the best out of your Jamstack site is if you're building a large Jamstack site that has thousands and thousands of pages. What I think is amazing is to spread it out into microsites with respect to their logical consents, right? For instance, if you had a site that had a product page that has a list of products that's coming from your CMS, or you have a blog section that's pulling in your articles from your CMS, or you also have a homepage that is purely static, right? What I think is it doesn't make sense for you to build all of that into one big bundle of site, because then the build times will be really high. So if you push a change into your docs page, for instance, then it's going to rebuild the entire site. It will rebuild the home page, it will rebuild the docs page, it will rebuild the products page, it will rebuild the blog section. Your entire site will have to rebuild for you to get the changes to preview. And that is where I think microsites can be really powerful. So if you build your docs site as a different site that is independent of your primary site, and build your blog section as an independent site, and build your product page as an independent microsite, you can use Netlify redirects and proxies to tie them back together into the primary site and just point to them individually. And that way, content changes to large sites will not affect the entire application. So basically now, if you update your docs, your homepage and your products page and your blog page won't have to rebuild. Just the docs page will rebuild. And that can significantly change your build times and give you much better development and deployment experience. With that, I will say thank you for tuning into my session and hanging out with me while I go on and on and on about the Jamstack. Once again, if you'd like to keep in touch with me, I'm Kenny_IO on Twitter, and I will also be available in the chat section to answer a few questions if you have any. Thanks for having me, and goodbye.
Thank you, Ekene. These are wonderful insights. And I'm reminding everyone that if you want to ask our speakers questions, you can do that on Discord. You can also check out the sponsor booth and talk to other members of the conference. Wow, time flies fast, and it is time to announce our last talk for today. Now, you may have probably seen one of our next speaker's tutorials online, because you may know him as Chris in Code or Chris Sev, and he is going to show you how to build a Jamstack site with Strapi and Next.js in 25 minutes. No spoilers, just welcome Chris on stage.
Right on. Thank you so much for that intro. Hey, everybody. I am Chris Sev, and I am so happy to be here. I am absolutely a big fan of Strapi, have been for a while. And so an intro from me. My name is Chris Sev. I'm a senior developer advocate at DigitalOcean. And my entry into DigitalOcean came when I started a blog called Scotch.io. And Scotch.io got acquired by DigitalOcean about 1.5 years ago. But blogging is really important to my life, to writing, CMSs, all that kind of stuff. That's kind of my start in the industry. So the reason I really like Strapi is because it's a CMS that gives us everything out of the box, and you don't have to kind of muddle through and build your own CMS. And I'm kind of speaking as, experience and that grumpy person that says, you know what, I've built that before, I wouldn't do it again. But I will say it was a great learning experience to build Scotch.io from scratch using Laravel. It started on WordPress. We switched over to Laravel and got to build a CMS and see how all of the inner workings and SEO and all that fun stuff works. But I will say that Strapi, it lets us do all of those things that we had to build by hand out of the box, which is really, really nice because we can get up and running and focus on what our customers really care about is our content. So today, this talk is jamming on Strapi. I definitely want to talk about the Jamstack and how we can build it using Strapi and how we can build a blog in the 30 minutes that we have together. And that's amazing that we can build a blog in the 30 minutes. So let's go ahead and do that. And we'll be doing the back end with Strapi, and we'll be doing the front end with Next.js, which I think, I get this question a lot. What would you build a blog in today? Like, what would you build a modern blog in? What stack would it be? I think it would be Strapi and Next.js. I love the combination of the two. We'll be using a methodology called the Jamstack. And the Jamstack, the J stands for JavaScript, the A stands for APIs, and the M stands for markup. And what that essentially means is we have a JavaScript front end that is kind of decoupled from our back end, which is our APIs. So the cool thing about Strapi is that it gives us an API and a CMS out of the box. And we'll be building that in just a second. And the cool thing about Next.js is that it comes on the front end side and it is JavaScript, and it can pull data from our CMS and also statically render it so that we get HTML and we serve HTML to our customers. And that makes our sites incredibly fast. And that's what the Jamstack is all about in my mind, is about speed and security. So we'll show you how to statically generate a Next.js site and build a blog using Strapi and Next.js. So to start us off, we have Strapi here. We're going to create a brand new Strapi app, and we're going to set this up. We're going to build an API, and we're going to get it all ready for Next.js front end. So let's go ahead and get started. Here's my terminal right here. I am going to say npx create Strapi app, and we're going to say StrapiConf backend, and I'm going to do quick start because quick start is going to tell Strapi, hey, could I get an SQLite database set up for me locally, and I don't have to set up any larger size databases like Postgres, MySQL, Mongo, any of that stuff. SQLite is great for what we're doing locally. And then when we eventually push to production, maybe we're using DigitalOcean's app platform, which is DigitalOcean's new platform as a service. We can say, hey, here's Postgres. Can you hook into Postgres now? And Strapi can say, no problem. You know, I'm just going to switch over from SQLite to Postgres. Easy cheese, just changes in the config files. So we'll let this go ahead and run. And while this is running, I kind of want to talk about a little bit more of the Jamstack and Next.js itself. So Next.js has two ways to render a site. And that's statically render it, where it's going to create all of the HTML files for us. And for a blog, that really makes sense to have static sites that we can generate and then serve from a CDN. That's going to be the fastest possible way to serve a website for our users. And the reason it's the fastest possible site is because we're just serving a full HTML page. There's no backend processing. There's nothing like that. So that's step one, is a statically generated site. Step two is what is called incremental static generation. Oh, and here's Strapi, thank you. Is called incremental static generation. And what that is saying we can't statically generate the entire page, all of our pages, because let's say we have a site that has 10,000 pages. We can say statically generate the site one page at a time every time a person visits that page. So when the first person visits a page, create an HTML file, and then the second person visits, we say, hey, here's our HTML file, take that HTML file. So we'll show you how to do both. Let's go for Chris right here, Sevilleja at DigitalOcean. So I'm going to set up Strapi real quick. Type in a password, and just like that, we have a CMS up and running that we can use to build out our APIs and let people come in, edit content. Amazing. I had to build all of this by hand in Laravel, which was, again, a great learning experience, but a lot of time spent. It maybe took 8 months to build that CMS. And here we are, 5 minutes in and we have a CMS. So fantastic. All right. We will click create first content type. So for this demo, we're going to do a blog, which is the de facto kind of Jamstack application. You can do this for any other sort of site where you have data and you want to show data. So you could do this for like an e-commerce site where you had products. I'm going to do post here, but you could do product, and then you can build out your products for your e-commerce site. You could do post, you could do cats, animals, anything you think of can all be handled by Strapi, which is really fun. So we'll go continue. And we are going to start building out this content type called post. I'm going to have text for title. That looks good there. I'll click add another field. I'm going to have text for the slug because a blog usually needs to have a slug in the URL, right? Well, I'm going to do that. Add another field. We're going to go for number. Let's go for likes. And this is cool here because we can say, hey, you're going to be an integer, advanced settings. I want you to default to 0. So all likes are going to be starting at 0, which makes sense. And then we can increment as we go along. I'll click add another field. And since this is a post type, we're going to have rich text, which is going to be the content. Now, the cool thing about Strapi is I'm going to do one more thing, and that's going to be a relation. And we'll say, hey, each post should have an author, and an author should have many posts. So one user has many posts, and that makes sense right there. You could even do something like a post has and belongs to many users. So you can say, well, one post is co-written by like 3 people. Super cool there. So we're going to say author and posts. You could also call this user instead of author if you wanted to be kind of similar to the database naming scheme, but I'll just do author. It makes sense both ways. All right, and I think that's it. So here it is. Post is title, slug, likes, content, and author. And I think that looks pretty good right there. So I'm going to go ahead and click save. All right, so here is our new post type. We have title, slug, likes, content, author. We'll go over to posts and let's create one. So I'll go add new post, my first post, my first post. And then let's go down here. Hi there, I'm a post. And notice you can choose your author right here. We don't have any authors just yet. We'll create one in a second. And I'll click save. Now, the cool thing about this is that Strapi by default comes with a draft and publish system. So let's say you have posts that you want to put in draft stages. You want somebody to come in and edit it, and then they can publish it. Draft and publish is right here. So now it's published. It should be viewable from our API now. So to show that off, we'll go to localhost 1337/posts. But notice that it's a 403 forbidden, which means that we can't view this resource. And this is actually something that Strapi does across the board. It just says, hey, all resources are going to be private until you explicitly set permissions on it, which is, I think, a really good policy to have. So we're going to go back here, and we're going to make sure that posts can be seen publicly. So we can go down to settings right here. We can go down to users and permissions plugin. We'll click roles. And now we'll click public. And here, if we scroll down, public people can see posts, and we can say we can count them. You can find all of them, or you can find a single one. All right, so now let's go save back to our API, and we should be able to get some data now. I refresh, and check that out. It's an array of posts like that. Super, super nice right there. All right, so that looks good. Let's go ahead and create another post over here. Let's go to posts. Let's go for my second post. My second post. And there is a way to auto-generate a slug from a title. And I'll show you how to do that in a second. My second post. We'll click save and publish. Now let's go ahead and author so that we can actually post an author to these posts. Add new user right here. I'm going to just do Chris, Sevilleja at DigitalOcean.com. Password, right there, confirmed on, cool. And now you can go from here and you can say, okay, well, let's say Chris wrote both of these posts. Super nice, super easy UI right there. So I'll click save. So now Chris is the owner of both of those posts. This is a user that exists now. We can go back to posts. Everything looks good there. We can go back to the API, refresh, and now author comes out of the API and gives it to us so we can actually use that author in our API and our front end. The last thing I want to do on the Strapi side of things is make sure that we can auto-generate the slug from the title, because that makes sense for a CMS to do. So we're going to go over to our terminal, cancel that out. We're going to say StrapiConf backend. We're going to npm install Slugify, which is a tool to take a string and actually turn it into a slug. And then we'll rerun npm run develop. All right, so I want to show you something really cool about Strapi is everything you see in the dashboard here is going to correspond to something in code. And what I mean by that is we have content types, we have post, and we have 1, 2, 3, 4, 5. So this isn't just in the dashboard. Strapi actually gets this data from a file. And I'll show you where that is. If I open up VS Code, click open, and I open this new folder, here in the API folder, in the post folder, under models, post settings.json, check it out. Here is the posts. Here are the attributes. We have title, slug, likes, and content, and author. So these are all of the things that we just kind of clicked in the dashboard to create, but Strapi says, you know what, I'm going to put it in code. So the really cool thing about this is anytime this changes in code and you commit it to GitHub, you can kind of see how the data changed in your GitHub history. But the one thing we want to do is make sure that we can say when you are saving or updating a post, take the title, turn it into the slug. So I'm going to go over here. We're going to say life cycles right here, and I'm going to say async before create has data, and async before update takes params and data like that. So what we're going to do is we're going to say if data.title, then data.slug is equal to slugify data.title. And also, you can pass in lower is true to kind of lowercase it. We're going to take this entire thing and paste it right in here as well. And let's make sure we require slugify. Oh, sorry, slugify is equal to require slugify. There we go. So we have the ability now to say, oh, before you create a post, check the title and turn that into the slug. Or if you update, do the same exact thing. And you can also say, hey, if no data.slug and the data.title exists, then you do that. But for now, we can just say, just update it if data.title exists. So let's go test that this works. We're going to go back over here, go to our post collection type, my first post, exclamation. Actually, let's do like 33333, which makes no sense, but click save and check that out. The slug was auto-generated from that. Okay, let's take a step back and we're going to move to the front end where we can take this API that we've created in 10, 15 minutes. So easy. We're going to take this API, this data, and we're going to turn it into a blog site. So I'm going to go back to my terminal right here, open up. Actually, let's open up a new tab. We're going to say npx create next app, StrapiConf, front end. All right, so now we are going to go into StrapiConf front end, run npm run dev. And now we can go to localhost 3000, and this is our brand new Next.js application. Once it spins up, very nice. Okay, so we have our Next.js app. Let me go over here. I'm going to open up a brand new VS Code. I'm going to open up StrapiConf front end right there. And this is going to be our Next.js application. And we have pages here. Index is where we just saw all of that stuff load up. That's where it said, welcome to Next.js. So we're going to just delete all of it. Div, welcome to StrapiConf. Take over. Okay, there we go. And we don't need that anymore. Perfect. So the way that Next.js gets data and statically generates a site is a function called export async function get static props. So what this is going to do is get data from our API, pass it to our component, which is the home component above right here. And you're going to return that as return props, and then you just pass in an object. So to do this, let's go ahead and get data from our API. Const res is equal to await fetch HTTP localhost 1337/posts. Const post is equal to await res.json. And now we can pass in posts right here. All right, so that looks good. We can go up here now, grab those posts. And here we go. Let's say, welcome to StrapiConf. Actually, let's wrap that in like an H1 and close that H1 and say post.map, post. And this is how you loop in React, right? So we're going to say div key is equal to index post.title. There we go. Okay, so we have H1 to say welcome to StrapiConf, and we are looping over the posts to say, hey, here is the post title of all of our posts. And if you wanted, you could even say by post.author.name. There we go. Okay, so let's make sure that this works. We haven't actually tested this code yet, but I'm hopeful that this works. So let's go over here. Oh, property map of undefined. It didn't work. Let's go see what went wrong. It looks like there are no errors in our logging here. That's still running. That's good. Okay, let's go check it out here. Oh, I just had a refresh. Wow. Okay, so it looks like my first post by name didn't come through. Let's go double check what happened. Let's see. Let's console.log up here. Posts. Just so we can see what's coming through. Console.log debugging. Welcome. Here we go. Inspect console array. Author is username is what we should be pulling, and there is no name property. So let's go ahead and do username. And now I'm getting confused between Strapi's backend and Next backend. So I'm going to close the Strapi one. Close that out right there. Post.author.username. There we go. And that should work. I'm going to do this right here and this right here so we can see. And that's statically exporting a site. So what I'm going to do here is we're going to go into our package.json. And there are scripts here for dev, build, and start. We want to say export. And that's going to be next build and next export. So let's go ahead and run this export command. I'm going to go over here and actually cancel that out. And we'll say npm run export. What this is going to do is actually going to statically generate this page. So if you're using React, right, it would go get the data from our API after a page loads. But if we do it in get static props, like we did right here, get static props, this is going to run during the build. So Next.js is going to say, okay, let me go grab all of these posts. Let me look at what this component is going to look like. And then I'm going to actually just turn that into an HTML file. And you can see that here under this out folder, index.html. It's all minified, so it's performant. But down here, if you scroll down, all of our data is kind of living right here. So that's the benefit. There we go. Welcome to StrapiConf, my first post, and it's right in the HTML. And this is going to be the fastest possible way that you can give a site to your users is through static exports. But this may not be the strongest because let's say you have 20,000 posts. it may take a little bit of time to do the build. And if you changed one file, to update 20,000 files because you changed one doesn't really make sense. So that's why the incremental static generation way works really well. And you might be wondering, all right, well, how do I set that up? You don't have to do anything. Instead of running the export command, you just run npm start. And then Next.js will say, okay, first person that comes to this page, I will do get static props. And the second person that comes to this page, I'll just give them the HTML that I just generated. So that's a really amazing feature of Next.js. But you might be wondering, next, okay, well, we have the home page. How do we get to individual pages? To do that in Next.js, we are going to create another page. And you might be wondering, well, Chris, do we have to do like my first post 333.js? And then we do another one for my second post.js? That wouldn't really be scalable, right? We wouldn't want to do this for 20,000 posts. So what we do here, let's delete these, is Next.js has the concept of dynamic routes. So we're going to wrap this in slug.js, and anything in the brackets is going to be dynamic right there. So to set this up, we are going to say export async function post. And we need to tell Next.js two things. One, step one, tell Next.js about all of the posts that we need to make. And step two, tell Next.js how to get data for a single post. And then pass that up to the post, which is going to be here. So we're going to pass that in as a prop. All right, so step one, we have a handy dandy function called export async function, and that's going to be get static paths. And down here, we're going to have export async function get static props. And this is the structure to these three functions can generate 20,000 posts. They can generate 50,000 posts. All of these are going to handle thanks to these two functions right here. So let me show you how to set that up. We are going to say const res is equal to, we're going to pull from our Strapi API, await res dot, or sorry, fetch HTTP localhost 1337/posts, const data is equal to await res.json. And we can actually call this posts right here. And then the way that this works is you are going to return paths, which is an array, and fallback, which is false for now. So that's how that's going to work. But the way that paths works is you have each one be an object where you say slug is going to be blah, or my first post, like that. And so on and so forth. And this is how Next.js is going to know how many pages to dynamically generate. Is this array right here, paths, and then basically it's going to pass this slug down into this one right here as params. So that's kind of the two-step functions of get static paths and get static props. I know it's a little confusing between the two, but here we go. We're not going to write all of these out by hand, right? So we're just going to say posts.map post, and let's generate it right here. We're going to say params is equal to slug is post.slug. So now by doing a map over all of the posts, we are able to generate all those pages. And then down here, we'll do the same exact thing. We're going to say const res is equal to await fetch HTTP localhost 1337/posts, and then we're going to say slug is equal to, and I got to turn this into a template string now, params.slug. So we're pulling the slug out of params now. And we're going to say const data is equal to await res.json. And then we can return props is going to be post is data 0, because Strapi will return data as an array, and we just want that first array since it's just one post. All right, so those two are probably the hardest parts of Next.js, is get static paths and get static props together. But we are done and able to build a 20,000 page site, a 20-page site, a 50-page site. All we have to do is just keep adding to our Strapi dashboard, and this would generate each one, which is really cool. And then down here, we just say return div, and then you can say h1 post.title, and then you could say a p tag right here by author.username, and then a div right here for post.content. And again, this goes for everything besides posts. You don't need posts to do this. You could do this with e-commerce. You could do this with any sort of content, but the technique is the same. You're going to use get static paths and get static props and this dynamic route. So let's see if our site works, but we need to have links, right? So we're going to say link href is going to be posts. Sorry, we're going to have post.slug there. And there we go. I know that got a little messy right there. Close that link. And the way that Next.js wants it is an A tag and an A tag like that. So now we have the link that's going to link over to each post. And I got to import link from next link. Like that. All right, that's a lot of coding without testing. So let's go see if everything works out okay. Are you still running? You are not. npm run dev. Okay, that looks good. Let's go over here. It is pulling everything from our API. We have our homepage that lists all of our posts. We can click my first post, and it went to my first post. There we go. The default export is not a React component in page slug. Okay, so let's go see what's wrong there. It probably is a quick typo. Export async function. Export default. There we go. And are there any other defaults? Nope. Okay, so let's refresh this. Uh-oh. Objects are not valid as React children. Okay, let's go check the render here. Export default. Oh, async function needs to go. It's not an async function, just a function. So there we go. My first post by Chris. Hi there, I'm a post. So that looks good there. And then we can go back to the home page, go to my second post, and it pulls the second post data like that. So that's really nice. And it could go on for as many posts as we want. And all of the data is coming from Strapi. And we're using Next.js is really just two files. Index right here, where we loop over all of the posts. And then slug, where we show each post. So the next steps here are to actually design out each page, bring in a CSS framework like Tailwind CSS, which I'm a big fan of lately. But this is the foundation for a Jamstack site. Get static paths, get static props, having a great CMS that's backing you, that gives you an API like Strapi, all of that great stuff will lead to a great Jamstack, a great fast site, and then you just add on your styles and you're off to the races. The last thing I want to do here is let's npm run export here. Let's see how many pages we can get built. All right, let's let that run. Here we go. It says, check it out. It discovered there was my first post, my second post, and it went ahead and created those files for us. So if we go back here, go to this out folder, there we go. My first post, my second post. And now we're able to serve HTML from a CDN if we deployed to DigitalOcean's app platform. And we are in good shape for a Jamstack app. So I hope you enjoyed that as far as building a Jamstack app using a Strapi backend, Strapi CMS, and a Strapi API. And check that out. We did it all in 30 minutes, and we pulled all that data in Next.js, and we're able to make a really nice Jamstack app. All right, that was a lot in 30 minutes, and I hope this is helpful for you to go build out any sorts of apps that you have a CMS backing it. If you want, definitely come hang out with me and say hi on Twitter. Chris__Sev is my handle on Twitter. I'd love to chat with you there. But all in all, thank you so much for coming. I hope you enjoy the rest of StrapiConf. I know I will. And thanks for watching.
Thank you for the fantastic talk, Chris. That was an intensive jamming session, and it's always exciting to see you build things with Strapi. And that was our last talk for today. I think all of our speakers deserve a round of virtual applause. and let me know on Twitter which talk you liked the most. Don't forget the StrapiConf hashtag. Now, this was the last talk, but our conference still goes on. After a 15-minute break, we're going to have several workshops held by our sponsor. To participate, you only need to register. If you haven't done that yet, please go to conf.strapi.io to the workshop session, select whatever you like and register, and I promise this is going to be super intensive and informative. And on this note, I'm saying goodbye to you as an MC for today. It's been a pleasure having you all and MCing for you, even if we are all in different parts of the world. And let's keep talking on Discord, where you can also chat with our community, our speakers and sponsors. Have a great night, great day, great time, and see you. Bye-bye.